Our next speaker has a question for you, and that's, are you tired of navigating through data sources and logs while troubleshooting AI product glitches? Join Liliya Akhtyamova, I hope that my pronunciation is good, senior data scientist and ML engineer at ICIMS, as she unveils a game-changing solution in her session, Mastering AI Issue Debugging, a Data Scientist's Guide. Liliya, armed with a PhD in NLP and over 7 years of expertise in cutting-edge AI systems, shares insights on simplifying the debugging process. Her talk focuses on developing a user-friendly interface that consolidates AI services-related information. This solution empowers not just data scientists, but also support teams, testers, and developers to efficiently troubleshoot and debug AI projects. Please welcome. Please have a patience. Just a few seconds, and Liliya will be ready. Please. Can we start? Ms. Akhtyamova, please welcome, join us on the stage.
Thanks for introduction. Can you hear me well? Okay, let me adjust a bit better. Okay, great. Okay. Yeah, hello everyone again. So my name is Liliya Akhtyamova. As I was introduced, I'm working as a senior data scientist, ML engineer at iCIMS, a company that, a cloud-based company that builds solutions for HR and recruiters. So when you apply for a job, it's probable that you interact with our software at that stage. And yes, welcome everyone to this conference and to the talk. And before we start, I just wanted to quickly ask the audience how many data scientists are here and you're building ML services through APIs. And familiar with telemetry observability tools, using them for debugging issues. Are any here in the audience? Okay, right. Okay, some. Okay, yes, it's very often that not only data scientists, but people from a software development world do using these tools, but today I'm going to introduce you from data science perspective. And okay, great. So before we start off, I just wanted to quickly go through agenda. First of all, I will describe main concepts just very briefly. What is essential for data scientists to know when debugging. Then I will quickly introduce telemetry pipeline and main vendors in that area. And then data scientist troubleshooting process, maybe you do it differently, but that's how we do it and why it was the cause of doing an automation. And then I'll walk through a demo of DO that we built. It's not exactly that we did, but I just replicated on a smaller example. And then the conclusion. So let's kick off. And here's just a brief introduction of the concepts. And first of all, let's start with the topic of trace ID. So in software as a service companies who provide software as a service products, the service delivery is very often done through APIs. And most commonly, those are REST APIs. And when an API call is made, and a unique ID is assigned, which unites all the spans for that particular request. And this is called a trace ID. And knowing this ID allows engineers, and as I described, also can allow data scientists to drill down on issues and also to observe the performance of the API. In software development world, so the software developers, probably if they're here also in audience, they should know it much better than I am. And it's a very essential, tracking of API performance is very essential. It allows to navigate system upscale or downscale based on the system load, and tracking any performance issues, and adjust the business logic. But from a data science perspective, we can also, if there are issues with our machine learning product, sometimes that's not a software engineering issue. It's a data science issue. It may be issue with our logic or machine learning performance of some library, deep learning library, for example. So in this case, the issue propagates to us after triage process, and we need also to navigate to drill down, to trace, to go to some tooling, understand what payload, inputs, outputs, and what result, and what model was executed, run debugging process. But these tools are very often now the starting, but not adjusted to deliver data science metrics. And in this case, sometimes data scientists build a custom metrics, which is also possible, and that's what I introduced in this, my example. Let's go further. And here's a rough telemetry pipeline, a look at the rough telemetry pipeline. And on the left side are some providers or collectors for metrics, logs, events, and traces, which collect data, and then they further the data goes to application performance monitoring and observability tools. And it's not a whole list. There are many more tools, and some application performance monitoring tools can also collect data, and vice versa. So I'm very curious how you're familiar with those tools, and pro software engineers for sure, and for data scientists, maybe the storage, Amazon S3 and other provider storage, that's something that we are most familiar with. We use it also for training models, storing data during training and other functions. So let's go further. And here's the usual pipeline when debugging an issue as a data scientist very often. So we hop on the corporate VPN, and then we perform very often the two-factor authentication, and then we do clicks and go to needed dashboards we build or to run queries. And we find necessary fields, and then we analyze the data. Sometimes we download, we aggregate it, maybe go to Jupyter Notebook to run this analysis, or writing a Python script. But all this process should be repeated many times very often when we're trying to understand and rerun the queries, understand the root cause of the issue, and can be sometimes very resource-consuming and tiring process and creates a lot of overwhelm. So the question is, can we automate that process? And as I discovered that, yes, we can do that. And let's look at how we do that. And I prepared a small demo. So now actual topic is LLM. It's everywhere, and in almost every company, people starting to play around and build LLM-based services. It's very often that, yeah, the services are delivered as APIs. And here's a demo of a tool that built with Python and LangChain, using LangChain framework, and delivered with a fast API through LangServe. And this is Azure GPT 3.5 model. And it has a retrieval-augmented generation or architecture. So maybe you attended yesterday's talk and you know a bit about it. But if you don't know anything, just don't worry. It's not that important. The most important is that that's some endpoint, REST endpoint, and it gets some input data and produces some output data, and that's all we need for this particular demo. And the task that I was tackling in the answer question, given a collection of documents about Chronicles of Narnia movie characters. And let's also cover what metrics and logs we store. So business logic metrics are stored to New Relic. In our company, we also use other tools, but I will demo New Relic. And we, in this particular case, collect data about the length of the input, user input, and the output length. So maybe there's some issue that the output is produced very short. And in this case, we can debug like what exactly is happening. And we can track down the performance of our model, also what's on average the length of input user provides, what's the output length of our LM. So many metrics. It's only one example metrics we can generate. And then payload data is stored to AWS S3 storage. And then when our REST API service is called, then this payload is produced with a trace ID with all identifiers related to that request, and it's stored to S3. And then documents from which we use for retrieval are stored in a SQL database. It can be any storage used in your company, but in this example, I used a very, very basic SQL database. And here's a bit of experimental. Let's see, hopefully it runs. Just want to show how the code is done and how it looks like, the produced results. So we call our endpoint. It's interesting if I can make it faster a bit, but probably not. So yeah, so this is a question. Let me look up to see. Hopefully you see as well what's, it's not too small. So we have a request. And it's asked about who defeats the White Witch. And then its result is produced. So that's Aslan from those documents. And trace ID is also produced. It's very often this information is hidden from the end user, but I just output it here as well to show. So here's we store this S3 logs, payload in a S3 bucket. And here we have it in a JSON. So let's have a small look. So here's our JSON. It's a bit simplified JSON, can have more information. So it can be a model card with all the configuration for the model and inputs, outputs. And there was also explanation field, which we asked LLM to produce explanation why I decided this result is valid. And then this is a new relic. And we see here the dashboard for this endpoint.py. With all software engineering metrics, which with the data science we don't care about, all the slots and the performance of endpoint. So we are not really that interested about that, and we go to our custom metrics. And for that, we need to go to query. Let's go to query. And the syntax is very similar to SQL. So we get our particular transaction from all the transactions for that particular trace ID. Yeah. So we're searching a trace ID, we're getting that particular run. And here we see the runtime. We can see like our input length, output length, and machine that it was executed on, host. And this is just a single endpoint, but there could be, in this endpoint, there could be a few functions or different endpoints from different other like, sources linked together, so it just could be like as much as like 5 or 10 lines. So here's, we also store these documents in an SQL database. And during debugging process and troubleshooting issues, we often look up if there are any available metadata or artifacts that we can look up. We also query SQL database. Oh yeah, that's an advertisement for CapCut. Okay, so next one. And for the troubleshooting part of that, we got a glimpse on what endpoint does and what metrics it produces. And for the next part is dashboard troubleshooting tool. It's done in Python. And I used Streamlit, which I really like. That's because of its simplicity, but still functionality that it provides for the user. For querying data, use New Relics, Node Graph endpoint that can be queried. And for getting access to S3 logs, both S3 library in Python, and for querying SQL database, SQLite 3. So you can see the stack is pretty, except for New Relic, Node Graph endpoint, is pretty standard. And here's again like how we can all unite this data. So going to the main part. So in this part, it's some setting. We define a login, and then we set up a Streamlit. So just some setup process. And then we setting up our database as well. So that's a database setup. And then we also connect to a session for the logs on S3. And yes, that's just some setting for the Streamlit. And then we input a trace ID. So if trace ID is provided, then we query our New Relic service and S3 logs and database. And there you can link as many services as you want. For example, Sumo Logic and Sure Datadog as well. They have endpoints that you can use to query your data. Maybe if you use CloudWatch, I'm sure they also have. So you can connect and get all the necessary field you need from the services, predefine your queries. So in the service, we provide the trace ID, service name, trace ID, then S3 bucket, and our pointer to our S3 database date, and then we connect to New Relic service, and we provide a New Relic API key and account ID, and then we can write a query same style as for SQL. And select our custom metrics or the fields that we are most interested in. So we run our query. So that's a query syntax. The syntax is as much as you saw it in the New Relic dashboard. In a node graph of the query is done through a node graph endpoint. So here is we call our service, and if the request is successful, if it succeeds, then we get our data and transform it to a data frame, and then we present it on a Streamlit dashboard. I hope I could speed up a bit to be able to have control of what is shown. Sorry, it's a bit experimental to show this way demo instead of putting blocks, necessary blocks on the page. So yes, so this is connect to S3. And the same process, connect to our bucket, and then we get given a trace ID, and trace ID is the name of the file in the S3 storage. So we can query by appending trace ID to the bucket and the folder name. So we query our logs there. And the same time is for SQL storage as well. So we connect, and for our outputs, we search if outputs we can find in SQL storage and get some additional information. What documents are available for our particular query. And here's finally a dashboard we built, so you can style it in any fancy way you want. But the most important part is that given our trace ID, we can enter that, and that's it. So we can get all the information we want about that particular query. We can drill down. We can output all necessary fields that needed for us to understand the issue. So the request was successful. The new reality metrics produced. What metrics? And there can also be metrics of how this input-output length, for example, compared to average on New Relic. So here's also S3 logs, the path to S3 file. And here's our output, this model card. There could be information about our model that ran that time, and particular prompt and question, answer, and explanation. And the SQL database, we get the reference documents. And we can see, is it really if, for example, customer complains, oh, we don't like the output, we can drill down to our documents and to check if the complaints of a customer are valid or not. In this case, we say, like, yeah, no, your complaints are not valid because it's a right output in that's what in a document, for example, or there could be some other issue. And you can defend your product, or you can improve it. So finally, our conclusions. As you can see that we can avoid that mundane process of if you store your, if you run API services and you store information in different telemetry providers or observability tools, you can simplify that process of troubleshooting, of debugging issues by automating the access and querying of observability tools. And the second part, that it's even easier with low-code dashboard tools such as Streamlit, Gradio, Dash, and others. So I'm really advocate for these tools. They're really easy to use, and they provide a really nice visual. Yeah, that's it. And thanks for your attention. If you have any questions, please ask me.
So, do we have questions, please? Anyone? Well, thank you. That's it. Ms. Akhtyamova, thank you very much. On behalf of the DSC conference team, I would like to thank you for being with us
Thank you.
today.
Thank you.
Okay.
Thank you.